Okay, here's quite a standard type of complex numbers question. We're told that z is the complex number x plus iy, where x and y are real. Part A asks us to find in terms of x and y the real and imaginary parts of z minus 3iz star. So z star is the complex conjugate. So we need to sub in x plus iy in for z, and for the complex conjugate it would be therefore x minus iy. Okay, so we end up with that. It asks for me to write down in terms of x and y the real and imaginary parts of that. So I'm going to take the real parts and the imaginary parts together. So having expanded that bracket, you can see I've got minus 3ix. I've got the minus 3 and the minus in the bracket makes the plus. I get I squared and I get a y. Now I squared, you should know, is minus 1. So that will change that to minus 3y. Okay, so now bringing those real and imaginary parts together. Now it's fine to leave it like this, or you can write them down separately if you want. Okay, there you go. Part A done. So for part B, it says find the complex number z such that z minus 3iz star equals 16. So basically it's saying, so that part from part A, for what complex number does that equal 16? Well, this is where we equate real and imaginary coefficients. So on the left hand side, my real is x minus 3y. On the right hand side, the real part is 16, so I can form an equation there. And then the imaginary part of the left hand side is y minus 3x, and there isn't an imaginary part on the right hand side, so that would be 0, so we'd have y minus 3x equals 0. And now we have two equations, two unknowns, so we can solve them simultaneously. So I'm going to times the bottom one by 3. Okay, so I've times that bottom one by 3 to get 3y minus 9x equals 0. And then I am going to use this one and this one. And if we add those, the 3y and the minus 3y will cancel. So we'll get minus 8x equals 16. So that tells me that x is minus 2. And then, like with all simultaneous equations, I need to find the other unknown, so I can sub x is minus 2 back in. I'll use the top equation. It doesn't matter which one you use though. So I've got minus 2 minus 3y equals 16. Adding 2 to both sides would give me minus 3y equals 18. And so a single y would be minus 6. And to finish, we've got to make sure we answer the actual question. The question is asking for find the complex number z such that that is true. Okay, so it's the complex number z that we're after, and z is equal to x plus iy. So we know x, we know y now, so we can sub those in. So we've got z equals minus 2 minus 6i. That's our final answer.